Joining us for this session this morning, organized by Energy Innovation and Reform Project to discuss some new papers that we're releasing on U.S. and Korean solar photovoltaic supply chains and U.S.-Korean broader cooperation on solar and clean energy. We're very excited to do this event today. It's part of a longer term effort here at EIRP to look at how the United States can work to promote the development and deployment of clean energy around the world, and especially how we can work together with our allies to do that. Over the last several years, we've produced a variety of research in this area, looking at U.S., Japan, South Korea cooperation on energy and energy technology, looking at steps that one might take to try to build a clean energy framework for the Indo-Pacific region. That's been another special focus of our effort. And I guess a couple of years now, we had a very high profile bipartisan task force actually looking at U.S. energy and clean energy strategy for the Indo-Pacific region. So this is one part in a kind of a much longer arc of work that EIRP is trying to undertake. We're really very pleased to have such a terrific group of speakers this morning. I'll introduce each person individually as we move through the program. We're especially pleased to have with us briefly at the beginning of this session Costa Samaras from the White House Office of Science and Technology Policy. Dr. Samaras is Principal Assistant Director in OSTP and also Chief of the Clean Energy Transition there. He works together with the Director, the Deputy Director for Industrial Innovation and others to coordinate federal clean energy technology policy. PhD in civil and environmental engineering and engineering and public policy from Carnegie Mellon, and someone with a long and distinguished career both as an academic and actually also as a working engineer on infrastructure mega projects in New York City. So it's rare to find individuals out there who have kind of experience working on projects, working in academia, and also working on policy matters. So we're certainly lucky to have people like Dr. Samaras. And thank you again for joining us this morning. Let me turn it over to you for a few minutes to talk about the administration's goals and policy.
Thank you so much, Paul, for that really gracious introduction, and thanks to the Energy Innovation Reform Project and to the distinguished panelists with whom I'm sharing this session. As Paul was mentioning, in the White House Office of Science and Technology Policy, we serve as a source of analysis and judgment for the President on the science and technology aspects of the country's health and economy, security, foreign relations, equity, and of course, energy. Our OSTP Industrial Innovation Team, really, we help develop innovation policies for the mid to long-term technology and really ensure the system's success for the rapid adoption needed for a clean, secure, and equitable energy transition. So I know that this group knows this, but I really want to accentuate it. The transition to clean energy requires bold action this year, next year, and every year through the middle of the century. It requires historical levels of deployment of existing technology and a commitment to clean energy innovation, unlocking new possibilities. And I look forward to reviewing these new papers that are coming out from this session. The electricity system that was built up for more than a century now needs to add 100 gigawatts or more of clean electricity every year. And this system needs the capacity, the transmission, the intelligence to accommodate new demands in the United States alone for up to 250 million electric vehicles, 100+ million electrified households and businesses, and major electrified industrial processes. And I know this group is well aware that electricity demand has not grown for more than 20 years in the US at a national level and could double or more in the next few decades. And that's even before indirect electrification for the use of electricity to produce clean fuels and manufacturing rapidly accelerates. So all of this is not just good news for the future of solar manufacturing innovation, it's good news right now. The Inflation Reduction Act makes the largest climate investment in history, touching every sector that produces greenhouse gas. But it's really the Manufacturing Renaissance Act, because it's fueling a clean energy manufacturing boom and bringing with it good-paying jobs, new economic opportunity, and healthier, more vibrant communities. And we're seeing it. We're seeing it right now. Companies are investing in manufacturing throughout the solar supply chain. Nearly $14 billion in planned manufacturing investments have been announced so far, 94 new and expanded manufacturing plants, and the amount of solar panel manufacturing capacity in the United States is now announced to be more than, that can power 17 million additional homes per year. This is more than 25,000 potential new jobs. This is a big, big deal. Other manufacturing is spread across the supply chain, from crystalline silicon cells to wafers to inverters to solar trackers. And that's the manufacturing. On the grid itself, in the United States, solar power represents about 1/3 of all clean power operating and plants on the grid since the beginning of the administration. Total solar power operating and plants have increased 85% since the start of the administration. And over the next 7 years, the Department of Energy expects more than twice as much wind, solar, and battery deployment as there would have been without the Inflation Reduction Act. President Biden's Investing in America agenda and the Inflation Reduction Act targets every stage of the supply chain for critical clean energy technologies. And that's why we're working with our partners and allies around the world to build sustainable, secure global supply chains for clean energy. The Inflation Reduction Act and bipartisan infrastructure law invest nearly $500 billion to build a clean energy system. Represents a substantial investment in clean energy deployment and innovation over the next decade, driving learning by doing and catalyzing and crowding in much more private investment from the private sector. Dr. Prabhakar, our director of the White House Office of Science and Technology Policy, often says that we need innovation to focus on what it takes to get the job done at the speed and scale necessary so that the climate takes notice. You know, let me finish up here. But this past April, I attended the Republic of Korea state arrival ceremony in the South Lawn of the White House. And on that day, President Biden said, quote, "We celebrate the ironclad alliance, the shared vision of our future, and the deep friendship that unites the Republic of Korea and the United States." His words from that ceremony ring true today. The country and the world are counting on innovators like you all to scale up a clean energy sector that helps us to get to net zero and leaves nobody behind. So let's all get to work. Thank you, and looking forward to the rest of the comments.
Thank you very much, Dr. Samaras. We appreciate you joining us this morning. We understand you have some other commitments today and may need to drop out here quite soon, but certainly appreciate your joining us. I will turn next to Professor Chinho Park. Professor Park is a distinguished professor at KENTECH, which is the Korea Institute of Energy Technology in Naju, which is in the southern part of South Korea. He's a former president of the Korea Energy Society, also a former policymaker who was managing director for the energy industry in the Ministry of Trade, Industry and Energy's Office of Strategic Research and Development Planning. And he's a former president of the Korea Photovoltaic Society. Dr. Yoon have together written a paper about South Korea's solar power industry. They will divide up responsibility for talking about that. Dr. Park will start. Chinho, please.
Oh, thank you, Paul, for your very nice introduction, and great to share this speech and event that you organized. Well, let me briefly go into the status and prospect of South Korea's solar power industry in a little bit of in depth. And we'll talk about the summary of the report in the second part by Professor Jae-ho Yoon. Next slide, please. Yeah. Okay, to give you an introduction, next slide. Maybe you're already familiar with South Korea. That we have a population of around 52 million, and our total electricity generation is close to 600 terawatt, and our demand is 594 terawatt, and the share of renewable is still, quite low, about 7.35%. And the share of PV is about 4.16%. We have currently that every 2 years we develop our electricity demand and supply plan by the government. The most recently released plan is a 10th plan, and based on the 10th plan, we have to have cumulative capacity of solar PV of 46.5 gigawatt by 2030 and 65.7 gigawatt by 2036. The Korean government is now working on the revision of the 10th plan into the 11th electricity plan. So these targets are subject to change because the current government tried to increase the role of nuclear compared to those who were in the previous government. But basically, the renewable portion will remain about the same. The fossil fuel section will go down further. Next. Okay, can go. Right. So Korea has been one of the top 10 PV module producers and system installation in the world, but recently the installation is going down. So last year in 2022, we were out of top 10 list from the world. Before that, in the previous 5 years, we always belonged to the top 10 list. But still, the cumulative capacity-wise, we're still in the top 10 list, listed number 9 in the world. So total, the cumulative installed capacity of Korea is about 25 gigawatt, which is actually, in terms of capacity, it surpassed the nuclear capacity. Nuclear capacity in Korea is around 24 to 25 gigawatt. That's the status of the installation capacity. Next. This is the trend of annual installation capacity from 2007. We had a slow growth, and since 2016, we had a very steep growth in annual installed capacity, reaching almost 4.6 gigawatt in the year 2020. Then after that, we are experiencing steep decline of annual installation, even though the installed capacity is reached 24 gigawatt. And as of end of 2022, the PV electricity occupies about 4.6%. So what happened after 2020? Well, we have many different regions that because of the time, I can just tell you the several key regions. So if you look at Next slide. Because of this, the installation, it shows some positive effect that the dotted line on the left is actual demand of electricity, and the colored red line is the demand pulled from the grid. So you can see about 10 gigawatt of demand is reduced due to the solar power, production. So the current the standby electricity capacity in Korea is around 100 gigawatt. So if we did not have solar, the peak demand reached almost 90 gigawatt, which is very close to the standby power. But the solar power reduced the burden from the electrical grid. So it did some positive effect. And also, if you look at the peak time, originally, previously the peak time was around 3 p.m. in the afternoon because people are turning air conditioning that time. But because of the peak demand, peak supply of solar, that peak time moved to 6 or 7 p.m., which is actually, helpful for the grid management. But if you look at the next slide, this fast deployment also caused several problems. That the too fast demand caused some social acceptance problems, but in the grid wise, the minimum demand actually became a big problem. Our maximum demand is close to 90 gigawatt, but if you look at the minimum demand went down to almost 40 gigawatt. So, imagine that we have about 25 gigawatt of nuclear base load, a base supply, and we have a peak supply of 24 gigawatt of solar. By adding those together, already more than 40 gigawatt if they operate at the same time. So because of this problem, that we have to curtail this almost 1 gigawatt of PV this year, especially those systems who does not have the so-called LVRT, low voltage ride-through function. We have to curtail those 1 gigawatt. And that this situation is getting worse and worse, that if we increase the capacity of PV. Another problem, if you look at the right-hand side, lower corner, this is a map of South Korea. The distribution of the PV systems is heavily located in the yellow region, which is southwestern region. The region the most PV systems are installed here is because there's more flat land available and not many people living in this area. So that means the electrical grid is not provided compared to other parts of region. So actually, this is accelerate and the more problem in the grid congestion issue. This becomes a big issue, and that's why that we have to decrease the speed of the deployment of PV systems. Next. So this new government came up with the new renewable energy policy that we still have a goal of reaching so-called national determined NDC target. To reach that target by 2030, due to the Paris Agreement, we have to keep installing at least 5 megawatt per year every year until 23 to reach our government target. But the actual installation is going down, and this year we expect about only half of this, which is 2.5 mega. Oh, I'm sorry, this is gigawatt. I'm sorry, this is a mistype. 2.5 gigawatt per year. So unless we solve these problems, we cannot reach the target we set. So the government is trying to introduce more favorite market systems, and also the private companies like Samsung or Hyundai try to participate in the Ali 100 Industrial Company Alliance, and also that solar cause the, the severe problem. So we like to increase more wind, until the 2030, so that the balance between solar and wind is currently about 90 to 10%, but we like to correct it to 60 to 40%. And another problem is that because Korea has a small land size, not many big area is left for installation. So instead, the government, that's why that we try to find installation in idle spaces rather than installation in farming areas or mountains, including building integrated photovoltaics or rooftop PVs in the factories, and the infrastructure related, for example, irrigation and drain channels PV installation. That we are promoting that. And in addition to that, Korea has been a powerhouse of the PV technology, advanced PV technology, in terms of in the area of the cell and module technologies. And so the government is still continuing the R&D support, especially for the next generation solar cells like perovskite tandem solar cells. And also this year, the Korean Congress passed a new law called Special Act on Promotion of Distributed Energy, which will help promoting the PV installation and the manufacturing. Next. Next, please. Yeah. And now I'd like to more, pay attention to our manufacturing, because the Korea has been a powerhouse for the solar manufacturing with the advanced technology and continued support on R&D and technology, development. But if you look at this manufacturing situation in Korea, especially the upstream area like polysilicon or wafer or ingot and wafer, it collapsed basically. From the polysilicon move all their factories to Malaysia or different area, and they stopped production in Korea since 2020, and wafer stopped production last year. The cell was doing okay, led by Hanwha Q Cells and Hyundai Energy Solution, but we had LG Electronics also producing cells, but we only have two companies left, and the cell production is starting to decrease. So why this has happened, as you may know very, very well, this Chinese, the solar value chain become very, very strong, and basically dominated all sectors of the PV value chain. And because of that, and also that the lagged subsidy from the government, the manufacturing is going through a very difficult time. And I had actually this morning, I had a meeting with the Korean Photovoltaic Industry Association, and they're complaining a lot about this. Only the installation company makes some profit, the manufacturing company is losing profit, and they're worried about continuing their manufacturing business in Korea. And together with that, the U.S. Inflation Reduction Act is a really big opportunity for Korean companies move to Korea and continue business for their sake. So next, please. I'll skip this one. So no, please, next one. Yeah, this is a more detailed one, and so that's why, as you know very, very well, that the OCI is expanding their business capacity of module from 300 megawatt to 1 gigawatt in Texas area, and also Hanwha Q-Cell investing a lot in Dalton and Barton, Georgia, module from 1.7 gigawatt to 3.1 gigawatt, and they have a module production plan of 8.4 gigawatt by 2040, and they're investing about 2.5 billion US dollar. And also they're acquiring the polysilicon company stock, the REC. So the Hanwha tries to build a complete value chain in USA, centered in Georgia area. I know this US business director, Mr. Liu, very, very well. He used to be factory manager in Korean factory. Now he went to US and he's in charge of the entire Hanwha business unit covering all the entire value chain. So for Hanwha, it's good, and working with the ally US, so they can keep maintain their business and still develop their technology to a higher level. So good for the community. But just by looking at the Korean side, not all the companies can go to US, because the small and medium companies, they don't have resources to run business in US. So even though Hanwha is going, a lot of this supply chains behind cell and module, for example, the parts, the films, and all this has to work together. So there's some separation going on. That Hanwha moving to US, but other small to medium supply chain companies is staying in Korea, and they're losing the cost benefit. They're losing competitiveness, and the Chinese product is still invading us. So somehow that for short term, this is a good solution for US and Korea, but I think for long term, we have to look a little bit in different way, that we can grow together and work together. So this is the situation in Korea. And after my talk and after David talk, the Jae-ho Yoon will suggest some recommendations to work with the US, the friends in US. Thank you very much.
Thank you, Chinho. Thank you very much. Jae-ho, perhaps you could stop sharing the slides. We will move next to David Hart, who wrote a paper on the US side of this equation. Dr. David Hart is a professor of public policy at George Mason University's Schar School of Policy and Government. He's an expert on science and technology policy, and also a non-resident fellow at the Information Technology and Innovation Foundation, ITIF, which many may know. And David was assistant director for innovation policy in the White House Office of Science and Technology Policy in 2011 and 2012. And his focus there was on advanced manufacturing. So David also brings this perspective of someone who's been both an expert and a policy practitioner. So David, thank you very much. I'll turn it over to you to the extent possible, please, around 8 minutes, so that we can preserve some time for questions at the end.
Thanks, Paul. Hear me okay? Everything look okay?
Yeah, looks very
great. Good. Excellent. So thanks for inviting me to join the project. It's been a pleasure to work with you and to get to know colleagues in Korea and get a sense of the Korean perspective on the solar PV industry, which is a really, really important industry for both of our countries. And there's no doubt that we can do a better job of collaborating and cooperating with our allies, and we need to do that. So my paper looks at U.S. policy, and it sets forth these three principles in the title here: diversification, domestication, and disruption, as the bases for a more integrated approach to U.S. PV manufacturing than we've had. Over the last 15 years, as Chinho pointed out, China has come to dominate this supply chain, and the U.S. response has essentially been ineffective. Now, we do have the Inflation Reduction Act, which Costa talked about, that is a game changer. And Costa alluded to the idea of a manufacturing renaissance here. And I think it is a step forward, but it's not ideal. So my proposal, I think, would lead to a more effective policy in the sense of achieving the goals, but also more efficient. I think we would get a better investment for the taxpayer money, and also improve our relationships with allies. That said, I don't want to sugarcoat it. It's not going to be easy. I'm not sure if it ought to be at the top of the list of our energy transition policies. But if we're going to do it, and we already are in the midst of that because of the IRA, we should give it our best shot. So that's my overall perspective on this. So I won't spend much time on this. Hopefully everybody on the call realizes that solar PV is going to be a centerpiece of the energy transition. And this is data from the IEA's net zero emission scenario. They just updated it, but I'm sure the basic picture is the same. Massive growth for decades. So this is a challenge that's going to be with us, that is supplying this energy technology for decades. So there's room here to do things over the long term. And as you can see here, China does control the various stages of the solar PV supply chain for crystalline silicon PV, which is the dominant technology now. So over 70% at each stage. And particularly, you can see the wafer stage almost uncontested globally. This happened basically around 2010, before and after 2010, by a couple of years. And in the context of a growing market, China moved from being a small fraction of the supply chain to being the dominant player. This is just the cells, but the same story is true across other stages of the supply chain. It was initially sort of accidental, but later was supercharged by the Chinese central government and essentially wiped out the competition in the rest of the world, including advanced technology companies in the US and in Korea and in Europe. The US response, I characterize it here as disjointed. Maybe that's a little charitable. We had rapidly growing domestic demand, as you can see with this black line, but despite the fact that the US imposed tariffs, which I won't go into in any depth, but there's an interesting story there, the supply really didn't grow much. So the orange, gray, yellow boxes, those are the supply side. And you can see there's a growing imbalance, and that's filled in by imports. The one big change you see is the silicon production, which is the base of the supply chain. So the very beginning of the supply chain, the US used to be the world leader in that territory, and primarily because of counter sanctions, counter tariffs put in place by China. That industry has been wiped out in the US. So not a very effective response in the 2010s, despite the fact that there were tariffs. So US installation costs went up relative to the rest of the world, but we didn't really get much of a supply response. And is that okay or not? It might be. I do think there's less risk with a PV supply chain than with fuel. So if there's a PV embargo, it's a lot less problematic than an oil embargo. But still, there are risks to it, and we've seen some of them already in recent days. So both of these entities, the IEA and the DOE, have cataloged the risks in detail, and I just summarized them in the paper. They include the risks of natural disaster, of ethical compromise, such as forced labor in Western China in the PV chain, the risk that Chinese government will stop backstopping its industry and cause those companies that are leading the world to fail. And the last one, which I've written more about, is the possibility that advanced technologies are being slowed down by the Chinese domination of this particular technological supply chain that's existing now. So that sort of sets up the framework for the policy proposal. But before I get to that, I should just say a word about the IRA. So the IRA is a game changer. And Chinho alluded to the fact that it has induced investment in the US, including from Korean companies like Q-Cells. It does so primarily through a tax incentive, which basically makes it about 50% of the cost covered by the federal government. So there's a subsidy on the supply side. And then there's a 10% bonus on the demand side. If you put in solar cells that were made in the United States, a certain percentage of those cells, you get a cheaper product there. So there are some strong incentives, and it's inducing this supply chain build out. These data in the blue box are from the Solar Energy Industry Association. But you can also see in that much of it, 85 gigawatts out of 155, is the very end of the supply chain, just the module assembly. And we're not necessarily getting all the upstream investment that we might. And so that means that the US is still going to be dependent on China, most likely for a lot of the supplies. So what should we do? And there's a lot of nuance here that I'm going to need to just gloss over. I would encourage folks to read the paper and to get in touch with me if you're interested. We have a very clumsy and rigid tariff structure and tax structure both. It would be great if we could target these more effectively and align them with the market. Not easy to do. Congress would have to authorize the executive branch to do that. And in the current political situation, there's not a lot of trust between the two branches, but I believe that would be necessary to really have an effective policy. We should be working with our international partners, so diversifying parts of the supply chain that are just ultimately going to be too expensive for the US to support. We're trying to subsidize our way into sectors where we probably aren't going to be competitive in the long run. And what we need to be doing is taking this period in which there are tariffs and in which there are tax incentives to make a globally competitive supply chain. And that means some parts of it need to be part of a global value chain rather than domesticated. So I think both diversification of imports and domestication of some parts of the supply chain are what we should be shooting for, not to have the entire supply chain in the United States completely self-reliant. So that means working with partners like South Korea, like India, to build out a global value chain that diversifies away from China. And then finally, to see if these new technologies, and Chinho mentioned perovskites, whether these new technologies can scale. The current paradigm is very successful, and we should be grateful. And I don't want to gainsay what the Chinese industry has done. They've really accomplished remarkable things by making the technology cheaper, more efficient, building out new production methods. But still, there may be an opportunity to disrupt it with new materials that would be both more efficient from a energy conversion point of view, but also potentially more useful in the sense that they can go into buildings more easily. They can be put on flexible structures. And as resistance to giant solar farms grows, and Chinho alluded to this as well in Korea, we see it in the United States, we're going to need more diversified products, and these new materials might help us do that. So that's my proposal, and I will look forward to the discussion.
Thank you, David. Thank you very much. So I will now turn to our last speaker, Jaeho Yoon, who's a professor at KENTECH, the Korea Institute of Energy Technology, vice president of the Korea Photovoltaic Society. He was the chief of the photovoltaic research department at the Korea Institute of Energy Research for many years, where he led research on solar energy and other renewable energy for about 10 years. Jaeho, also, I would encourage you really to be as brief as possible so that we can preserve some time for questions and discussion driven by our participants here today. But please take it away. Take it away.
Okay, so can you see my slide? So
Yep.
I thank you for kind introduction. Hello everyone, my name is Jaeho Yoon from KENTECH. So first, I'd like to thank for inviting me to this online meeting today. So also, I'd like to thank SPOR and EIRP for giving me a chance to think about and organize various various ideas for Korea's PV industry. So, okay, based on the information by Professor Hart about the current status and the issues of PV market and industry in Korea, I will now share some recommendation to Korean government or to us from the perspective of how the Korea solar industry can gain industrial competitiveness very briefly. So I think the key factors to Korea's PV industry is how to compete with the Chinese solar industry and how to secure a stable supply chain in the PV manufacturing process. So what we also need to consider is not only China's dominance in PV industry, but also the impact of policy such as America's IRA on Korean solar companies. So I would like to recommend U.S. South Korean collaboration in solar PV value chains that is trend showing as a highly desired strategy for both countries. In this slide, here are basic concept of friend shoring between the two countries. Friend shoring stabilizes the supply chains by ensuring reliable supplies of silicon materials and other essential components. So this helps mitigate the weakness in the global supply chain and enhance the industry stability. The second, the friend shoring provide opportunities to enhance competitiveness through collaboration with various countries and regions rather than reliance on national level effort. So this allows companies to utilize a diverse market and resource of supply to pursue flexibility and diversification. Lastly, friend shoring can improve technological innovation and knowledge sharing through the international collaborative research and cooperation project. It promotes the development of new technologies and facilities, the exchange of experience and knowledge, contributing to the industry growth. So based on this concept, I'd like to suggest several specific action items for the friend shoring and the gaining industrial competitiveness. So as mentioned earlier in the concept, the basis of friend shoring is to secure a stable supply list for silicon wafer by building new global supply chains that depend less on China. I think the Hana can play a key part in this effort through its U.S. manufacturing. So also South Korea government support for wafer factory at OCI polysilicon plant in Malaysia could also contribute in this concept. So at the same time, it is very important to pursue the bilateral South Korea-US research and development cooperation to regain the technological leadership in solar PV. Possible area for cooperation could include developing perovskite-based tandem cell technology and the integrated module technology, as mentioned by Professor Paul. So the second thing for the gaining the industrial competitiveness is to expand South Korea's domestic solar market. Most important thing is to accelerate the solar PV deployment to achieve target set in the 10th stage plan already introduced. So in order to do this, it is to remove a burdensome regulation that slow deployment and to provide incentive for system deployment, also support domestic companies in achieving their goals through the promotion of power purchase of PPA and policy to reduce solar PV LCOE in South Korea, especially soft costs such as acquisition and land use fees. Also, in the view of PV industry, it is to secure a stable 3-5 gigawatt annual domestic PV installation market to sustain domestic PV manufacturing. So enhancement and the diversification of Solar Korea's carbon certification system and link it with the emission trading system can play an important role for expansion of PV deployment in Korea. So, and last thing I would like to suggest is the technology, the innovation. So, it means that the acceleration, the innovation in areas such as tandem solar cell and integrated PV system. So, as I introduced the earlier, to first the key material component and the equipment companies that could drive the future solar market, perhaps including manufacture of durable packaging materials and the dry process perovskite material deposition equipment would be a new component or new market segment in PV industry. So it is to provide new government incentive for medium-sized model manufacturer and the innovation-based technology companies that produce integrated PV module for BIPV and floating PV, agri PV, and other specialized applications. So lastly, I think it is very important to leverage the domestic core industry in Korea, such as petrochemical, steel, and semiconductors, to boost competitive the advantage in the domestic solar PV manufacturing industry. So, okay, in summary, the friendshoring strategy based on Korea-US collaboration basically means securing a stable supply market by securing a stable supply chain and expanding the local manufacturing while simultaneously expanding domestic supply. In addition, the Korea-US partnership means that the Korean contribute by leading the development of core technology for next generation market, such as tandem solar cells and integrated PV. So I would like to understand the cooperation in the clean energy field between U.S. and Korea, which is listened to receive the increasing attention is in this context. So I have just presented some suggestions for security and industrial competitiveness in Korea. Thanks for listening.
Thank you very much, Chinho. So I'd like to use the remaining time here this morning for questions from our participants, and I encourage anyone with questions to type those in using the Q&A function at the bottom of the Zoom screen. While people think about that, maybe I'll start with while people think about that, I'll just ask here one question, perhaps to you, Chinho, if you don't mind. As you look at U.S. policy and the Inflation Reduction Act, in your remarks, you talked about some big positives for Korea and Korean firms, but also some maybe challenges or drawbacks. On balance, how do you view kind of U.S. policy, U.S. Korea cooperation on solar supply chains at this point? A net plus, a net minus? What's your attitude?
Well, thank you for the question. It is a little bit difficult question because that when you that in the global arena, in the global PV, the market or the industry wise, the Korea U.S. corporation led by Korean large conglomerate companies like Hanwha, it's actually diversifying and building another route of the global value chain in PV. So it is, I think, healthy to the global PV industry and the market. But if you look at just the Korean side, like I mentioned earlier, that only the major companies can operate in US, but to produce cells and modules, you need a lot of other parts with complicated supply chain structure. And those parts and the material is supplied by the medium-sized and the small-sized industries, which has developed their technologies in the last 10, 20 years with full of experiences and know-hows. And those small, medium-sized companies cannot all go to US to run their business. So they have to, most of them will stay in Korea. And there's some, what can I say, some, the breach or the disconnection in the domestic and the global supply chain that actually may weaken the domestic competitiveness in the supply chain. That can, in the long term, then maybe someone else can take their role, but we are losing the experience and the capacity, the building in the last 10, 20 years. So that's that I worried a little bit. Yeah.
Thank you, Chinho. So David, now I'm going to ask you kind of another tough question. This is a question that I get all the time. So you know, the United States obviously has a presidential election coming up. What happens in this area if we have a change of administration in the United States and we don't have an administration that's been as committed in this area as the Biden administration has been? Bearing in mind, of course, that on the narrow question of the tariffs, you know, that obviously has a history that extends before this administration.
Yeah, so I think we would have a mixed picture. I do think the antagonism towards China will, you know, continue, if not be ramped up, and we'll see, you know, across the board tariffs. I don't know that they'll be targeted particularly on solar, but I think we would expect that to continue. But the subsidy side, I think, will depend on the Congress, as well as the attitudes of states where this you know, funding is being received. And the theory of change that a lot of people are pursuing here is that as investments flow into places like Georgia, Alabama, other states that are Republican held, that they'll, you know, gain an interest in sustaining these policies. So it may be a bit of a race, you know, between those two things. Will enough investment come into enough places to sway the members of Congress? So I think, you know, if we look back at the previous Trump administration, there was some momentum sustained through that, despite the pushback from the administration itself, from the state level, from Congress. So I wouldn't expect it to be, you know, complete reversal, but I do expect it to be back pressure in a big way.
Thank you, David. And Chinho, I'll ask you a final question again for kind of a brief response. You know, just drawing on your background as a technology researcher, how much room do you think is left to improve the technologies around solar photovoltaic? How much more efficient can it realistically become? How quickly might we see some of the new applications that you and others described? And to what extent, can we expect, that we can bring down manufacturing costs further in the future? And I know this is like a lot of really big questions for just 2 or 3 minutes, but your thoughts on that would be welcome.
So yeah, so I'd like to answer in terms of the technology development in the solar cell technology or solar module technology to enhance the PV deployment. So as you see, recently many researchers are interested in the increase the cell efficiency by using multi-junction solar cells. So some researchers have reported that more than 33% solar cells astonishing result, I think. So the increasement of the solar cell can gain a new market as well as a new deployment the status. So also moreover, so some BIPV and floating PV so-called the integrated PV system or integrated PV module would be a new market or new technology for the expanding the PV's manufacturing. So actually, in terms of PV deployment, it took about 70 years for 1 terawatt PV. So by helping to technology into the example, the tandem or the integrated PV module, I think just 1 or 2 years for an additional 1 terawatt PV deployment. So I hope so.
Thank you. Thank you very much, Chinho. So we have one question from a participant, and I'm just going to ask each of you for a yes or a no, because we have very limited time, and I want to end on schedule. So just a yes or a no, Chinho, David, Chinho. Are there any scenarios where the United States and Korea can become independent of Chinese supply chains in solar panels or in other components like inverters? So yes or no, Chinho?
Yes, that's why you're proposing that friendshoring strategy.
Okay, David.
Over a long period of time, but not anytime soon.
Okay, and Chinho?
Hopefully, yes.
Okay. All right. Well, thank you so much to the 3 of you again for your papers and for your time today in presenting the papers and also your thoughts. Thank you to our participants for listening in today. And also to those who listen in online in the future. We look forward to seeing you all for future energy innovation and reform project programs. So thank you. Have a terrific day.
Thank you.